Welcome back, class. Today we're going to be covering section 3.3, and let's get straight into it. This section we're going to be, so in the previous section we covered variance and standard deviation, right? We're going to continue with standard deviation on this section, but specifically we're going to be looking for the z-scores, right? Later we're going to be looking for the percentiles, right? And then we're going to be looking at quartiles. And then finally, we're going to be looking at the outliers in data, right? So let's go ahead and get started with z-score, right? A z-score for a value is obtained by subtracting the mean from the value and dividing the result by the standard deviation, right? And for these for this first example, that specific numerical value, right? It's a value that's going to be given to you alongside with the mean and their standard deviation, and we need to find the z, right? There's going to be other examples where you're going to be giving the value itself, right? And by value, I'm referring to that capital X, right? See that uppercase X without the top bar, because we know that the X with the top bar is our mean, right? So whenever we're dealing in this case or in any of these cases, right, you may have to solve for z, and the rest are going to be given, right? You may have to find for your standard deviation, and all of these three would be given, right? So this is where our algebra skills are going to be come into play, right? So let's go ahead and get started with the question, right? The average age of senators in the 108th Congress was 62.5. Right, and just like before, right, I'm going to go ahead and start writing down what I know, right, the given. So I know the average, right, that's going to be my mean, that's going to be X bar, that's going to be 62.5, right? That 108th Congress, even though it's a numerical value, that doesn't really give me, I'm not going to use that value, right, in our formula. That's just a given. If the standard deviation is 11.5, right, that's going to be my S, right? Find the z-scores, right? So they're already going to tell me, right, that I already have to find my z. But here specifically, find the z-scores corresponding to the oldest and youngest senators of age 84 and 43. So that means I'm going to have to do this problem twice, all right? So my first z-score, right, let's do it for 84, right? So that's going to be my x. My x is going to be 84, all right? So let's go ahead and do it for my first z value, right? My first z value is going to be x minus x bar over my standard deviation. All right, my x for this problem, let's do it for the oldest, right? It's 84 years minus my average, which is 62.5, divided by 11.5, all right? Let's go ahead and compute that. That is 84 minus 62.5 divided by 11.5. This here, and let's do two decimals, right? It's going to depend what your homework asks. So it could be 1 decimal, 2 decimals, or 3. We'll go ahead and do, we'll do 2. We'll do 2. So I get 1.87. So my z-score here is 1.87 for the oldest senators. Now let's go ahead and do the second case. Right, the second case, and for the second case, my x is going to be the younger one, so that's going to be 43. 43 minus 62.5 all over 11.5, right? And that's coming from that same formula, right? So I'll go ahead and keep it consistent. I'll go ahead and write it out too, right? That's going to be x minus x bar over standard deviation. Right, and that gives me 43 minus 62.5 divided by 11.5. That gives me a negative 1.70. And that's it, right? That's all you would have to find. That's how you find your z-score. All right. So let's go ahead and move on to the next example, right? So here's going to be a little bit different, right? This part here is going to be a little bit different because you're going to be given your z-score, right? The z-score is going to be given. Now you're going to have to find the other values. You may have to find the standard deviation, the value, right, referring to x, or my mean, all right? let's go ahead and find that. All right. So the average teacher salary in a particular state is 54,139. Right. So I already know that's going to be right my X bar, my average. 54,139. The standard deviation, which is my S, is 10,320. Find the salaries corresponding to the following Z scores, right? To the following Z scores. All right. Go ahead. And since we're dealing with population here, right? I'm going to want to use, let's go ahead and copy this over, the bottom formula. But as we know, it's just the notation, right? The notation that we use, right? It's still going to be the same values, right? So since we're dealing here with a population, this is going to be X minus mu over sigma, right? And this means the same thing, right? So we know that my average is mu, and then my standard deviation is sigma, right? Awesome. So let's go ahead and plug that in, right? Let's go ahead and do A, right? So let's go ahead and do A, right? Because we know this is the formula we need to use right there. Go ahead and use A, right? So my Z score is given, right? For A, my Z score is given. My Z for A is going to be 2, right? So I'm going to plug this into that formula here. This is going to be 2 is equal to X. That's the value I'm going to try to solve for, minus my mu, which is 54,139, divided by my standard deviation, which is 10,320. And the goal here, right, is to solve for X, right? My goal here is to solve for X. So I need to go ahead and multiply both sides by that denominator, right? So I'm going to multiply both sides by 10,320. I'll do it to this side too, 10,320. Why? I can get rid of that. So I can get rid of it from here because I don't want any fractions, right? And 2 times 10,320, that's going to give me 20,000, what's that, 640 is equal to X minus 54,139. And last but not least, right, we're trying to solve for X. I'm going to go ahead and add this to both sides, right? This cancels out here, leaving me with, what is that? Right, this gives me 74,779 is equal to X, or X is equal to 74,779, right? That'll be my value. That'll be the X value. Let's go ahead and do another example, right? We'll go ahead and do another example. Let's do, so these values are going to stay the same. Let's do the last one, right? Let's do the last one, Z, D being negative 3.7, right? And again, I'm going to plug it into that same formula. Z is equal to X minus mu over sigma. My Z is negative 3.7 is equal to X minus 54,139 all over 10,320. And again, right, what are we going to do? I don't want that denominator, so I'm going to go ahead and multiply that to both sides. Multiply that to both sides. All right, this cancels out, which is exactly what I was looking for. And now let's see, what is that? 10,320 times negative 3.7, right? So let's go ahead and make sure we wrap negative 3.7 in parentheses to make sure we're multiplying. This is going to be negative 38,184 is equal to X minus 54,139. And again, very similar to the other case, right? To the last case. I'm going to want to go ahead and add both sides by 54,139. 54,139 to both sides, right? And this leaves me with x, or let's keep it consistent, right? Adding that together, I get 15,995 is equal to x. So our x is equal to 15,955. Very nice. All right, so let's go ahead. So this pretty much covers, right, the z-score for now, though, for now, right? Because there's eventually for the next coming assignments, we're gonna have to do more with this z-score, right? So let's make sure we fully understand how to find the z-score, because that's pretty much the halfway point for a lot of other problems coming up. All right. Now we have here the problem. Example 3, percentiles, right? So whenever we're dealing with these percentiles values, right, what we want to go ahead and do is arrange these our values from lowest to highest, right, in ascending order, right? So this is going to mean that the average weekly earnings in dollars for various industries are listed below. Find the percentile rank for each value, round to the nearest whole percentile, right? So this is going to be 450. Let's do 455, 459, 651, and 848. All right. And whenever we arrange these numbers, eventually, right, these values have to correspond to percentiles beginning with, right, something very, very low, let's just say close to 0, to something very high, right, something close to 100. For those of you who have taken the SAT or who ended up taking the GRE, right, to get into grad school, you know that whenever you're done with your score, they tell you where you ranked, right? If you end up getting like a 25th percentile, right, that means that your score was above pretty much the 25% of the lower half, right? And if you end up getting something like a 90th percentile, right, on your GRE score, on your SAT score, that means you did 90, you can say 90% better than the people with a lower score, right? So it gives you it's a ranking system, right? Now we're going to go ahead and do this with these values, right? So to find the percentile, right, you're going to count the number of values below the x, right? And our x is going to be those specific values, right? That specific values. So in other words, I want you to ask yourself to find the percentile of 450, right? Percentile 450. How many numbers, right? How many numbers are below 450? None, all right? There's nothing there. 450 is the lowest. So let's say that's going to be, right, 0, plus you're always going to add this by 0.5, right? You're going to add it by a half, divide it all by your n, right? You're going to buy it by your n. What's our n here? 1, 2, 3, 4, 5. So this is going to be 5, right? And then what we're going to want to go ahead and do is multiply this by 100. All right. 0 plus 0.5, that gives me 0.5 divided by 5 times 100, all right? And 0.5 divided by 5, let's get our calculator, right? This gives me 0.1 times 100. Go ahead and make it a little bit smaller. And whenever I multiply that by 100, I get 10, all right? So you would mark this as, this is, 450 is my 10th percentile, all right? Right, and then we're going to go ahead and do that with the next value, right? Let's go ahead and do this. Let's find the percentile for 455, right? And ask yourself, how many numbers do you have that are less than 455? Ah, it's just 1. It's going to be 1, right, which is 450. And again, you're going to add by 0.5 and then divide by 5 and then multiply by 100. Right? Multiply by 100. Multiplying by 100 is the last part you're going to do. So this is going to give me 1.5 divided by 5 times 100, right? 1.5 divided by 5, that's going to give me 0.3 times 100, which is going to give me 30. So that 455, that's in the 30th percentile rank, right? And we're going to go ahead and do this for 651, 848, 459, and let's go ahead and do that now. And here are my values. For 459, that is going to be the 50th percentile. For 651, that's going to be 70th percentile. And for 848, that's going to be 90th percentile, right? And this is all I would ask for you to find, right? But we have to remember that you may be asked, right? So this pretty much covers this section, right? You would just, and the key thing here is to remember to rewrite this in ascending order, right? From lowest to largest, right? Because if you don't, right, you could be giving the highest value in your data a lower percentile that it deserves, right? Than where it's at, right? So let's remember that. Okay, we're going to go ahead and continue with the same exact problem, right? We're going to go ahead and we're going to continue with the same exact problem, but right, your values, we went ahead and arranged them in ascending order. But now I'm asking you, right, for the same data, find the value, right, from the given 5 that corresponds to the 27th percentile, right? That corresponds to the 27th percentile. And the formula for that is going to be C, right? Where C is not going to be, C is going to be the value we're looking for, right? So if your C equals 1, it's going to be this. If your C equals 2, it's going to be this one. If your C equals 3, it's going to be this one. If your C equals 4, it's going to be this. And your C equals 5, it's going to be that value, right? So it tells you it's an index, right? It tells you exactly which value it's going to be. So let's go ahead and find that, right? The formula for that is going to be C is equal to N, right? Which we know it's 5 times P, right? The percentile is going to be 27 divided by 100, right? So it's going to be divided by 100. So let's go ahead and find that, right? This is going to be 5 times 27 divided by 100. What does that give me, right? Let's go ahead and find that. 5 times 27, that gives me 135. And 135 divided by 100 gives me 1.35, right? But we need to remember, we need to go ahead and round up to the next whole number, right? And this goes back to the previous sections, right? We can, right, if we're dealing with a location 1, 2, 3, 4, and 5, it doesn't make sense to say I'm in location 1.35, right? Well, which one is it? Is it 1 or is it 2? Well, here, since we need to round up, right? Rounding up 1.35 is going to be 2. So in other words, my index is 2, right? My C equals 2, that's going to be my index, meaning it's going to be my second value from ascending order, right? So it's not going to be 450, it's going to be 455, all right? So the value that corresponds to the 27th percentile is 455. Okay, let's go ahead and do another example, right, with percentiles, right? Find the percentile rank for each value in the data set. The data represents the value of billions of dollars of the damage of 7 hurricanes, round to the nearest whole percentile, right? So let me go ahead and arrange these in ascending order, and it looks like they already are, right? 2, 4, 6, 7, 10, 12, and 13, right? So let's go ahead and find the 30th percentile for this data, right? We said the formula is C is equal to N times P divided by 100. So I can find that C index, right? My N is going to be 1, 2, 3, 4, 5, 6, 7 times my percentile, which is 30, divided by 100. Right, 7 times 30, that gives me 210 divided by 100. That gives me 2.1, even though it's close to 2. Remember, we need to round up to the whole number, meaning it's 3. Right, so C equals 3. This is going to be my index. So I'm going to look for the third value from the left, right? Once it's already in the ascending order. So 1, nope, 2, nope. Ah, there we go, 6.6. So that means that 6.6 corresponds to the 30th percentile. Okay, now let's go ahead and move on to the next part, which is going to be quartiles. With quartiles, right, we're dividing our distribution information, right, and where the middle point, right, the mean is going to be your Q2, right? Let's go ahead and do something like this. It's going to have, so the graph should look like your lowest data value, your highest data value, right, something like this, your mid value, right? This here would be what's known as your Q2, right? This here would be your Q1, right? Which is going to be the average between your lowest and your mid value, right? And then here would be your Q3, which is the average between your mid and your high values, right? Where this here is 25%, this is 25%, this here is 25%, and this other here is also 25%, where, you know, arranging everything, right? Taking everything into consideration would give us 100%. So, right, one thing to remember is if your value is in Q1, right, if a value lands right there, that is the 25th percentile, right? Your mid, right, your Q2 is the same thing as your 50th percentile. And your Q3, right, what do you think? It's going to be your same thing as your 75th percentile, right? So let's go ahead and apply this, right? And in case you want to go ahead and know this specific part in the book, this here is in page, where was this at? Page 163, right? For section 3.3, right? Going over quartiles, right? So let's go ahead and apply this to my data, right? And of course, what we want to go ahead and do, move that somewhere there. What I want to go ahead and do is arrange my values in descending order, right? Let's go ahead and do that now. There we go. We've gone ahead and arranged these in ascending order. And look at these values, right? Just some food for thought, right? For the next slide. All these values are ranged 0, 1, 2, 3, all the way to 43 and 47. All these values, they seem to be spread out evenly, right? Right. It's not like if it was 0, 1, 15, 16, 18, you know, 34, 35, 43. All right. So this is going to play a big part in this next section. So to find Q2, right, here I'm asked to find the first, second, and third quartile. All right. So for my, let's go, generally the first one you want to find is going to be the medium of your data values, right? The Q2, right? So this here is going to be we said it's going to be the center value, right? So let's go ahead, and if I take this off, I can take this one out. Let me go ahead and center down onto the middle, right? I can take that one off. I can take that one off. Ooh, right? We had said that if my value was just one value in the middle, that would be my median, right? But here I have two values. So what does that mean? Yes, I need to go ahead and find the mean of those two values, right? So we said that's going to be one value plus the other value divided by 2. And what does that give us? Let's Let's go ahead and plug that in. And that here gives me 17.5. So I already know that my second quartile, my Q2, is 17.5, right? Now I want to go ahead and I'm going to split this right through the middle, right? Let me go ahead and split my points right through the middle, right? Because I have the same number on the left and same number on the right. And for Q1, I'm only going to focus on these left values, right? I'm only going to focus on these left values here. And now I'm going to go ahead and find, right? I'm going to go ahead and find the median there, all right? So if I take that one off, I take that one off, that's balance. If I take this one off, I take this one off, that's balance. Oh, it only leaves me one value, right? So that means that my Q1 must be 2, right? And I'm going to go ahead and do the same thing for the right-hand side now, right? We're going to go ahead and find that. We're going to go ahead and find Q3. I'm going to play that same rule. If I take the outer ones first and then focus focus towards the middle, I'm left with 35. Right, so this means my Q3 equals 35, right? Meaning Q1 equals 2, Q2 equals 17.5, and Q3 equals 35. Very nice. How was that? Not so bad, right? Very, very nice. And still, if you notice, we're still dealing with medians, right? We're still dealing with medians and with means, right? Whenever we're finding quartiles. And this is why it's very important from the very start, right? We all started strong. Let's go ahead and we all started very strong. Let's go ahead and just finish strong, right? And last but not least, we're going to go ahead and move over to quartiles. I'm sorry, to outliers. Now, to find my outliers, right? So one thing I mentioned before is, let's just say that you were plotting points, right? You were plotting these points, right? You made this survey, right? And from the data you were collecting, your graph probably looks something like this, right? Something like that. And for some reason, right, whenever you did the survey, you have an answer right over here. That is an outlier, something that's just out of the bounds, pretty much out from the norm, right? And we can go ahead and find this numerically, right? We can go ahead and find this numerically. The first thing we want to go ahead and do, of course, right, is check the following data set for outliers, right? If there's any more than one answer, separate them with commas. So the first thing we said we want to do whenever we're dealing with data is arrange them in ascending order, right? 234, 236, what's the other one? What's that? 241, that 245. What's the other one? 253, and I feel like I'm missing one. There we go. 280, 282, right? Give me 1, 2, 3, 4, 5, 6, 7. Right, 1, 2, 3, 4, 5, 6, 7. Oh, I'm missing one. Right, which one is it? Give me 1 second. 249. Right. It's always double check. Right. It's always double check, especially just double check at home. Right, so we can get into the habit, especially when the exam comes around the corner. Right. Right. So there we go. My 8 values. Right. So the first thing I'm going to go ahead and do is find my Q2, right? My Q2, right, I have one, since I have 8, that means I can split these values right in half. I can split this right in half. And since I don't have an exact middle value, right, since I don't have an exact middle value, let's go ahead and do this one for practice, right, finding Q2. So that means I'm going to add 241 plus 245 and divided by 2. Let's see what that gives me. Oh, nice. This gave me 243. All right. Now let's go ahead and find Q1, right? Q1. Q1, we said we're going to focus on the left side of that split, right? Left side of that split. There's nothing in the middle, but that's fine, right? That's completely fine. We're going to do the exact same thing, right? If I narrow these out and I'm left with 2 in the middle, I'm just going to go ahead and take the mean of the middle. So this is going to be 234 plus 240, look at the other, 234 plus 236 divided by 2, right? And this here is going to give me 235. And I'm going to save that. Let me go ahead and find Q3 while I'm at it, right? Let me go ahead and find Q3, the same thing, right? It's an even number of values, so I'm going to go ahead and get these middle values. I can take that one off, I can take that one off. I'm left with those two. Let's go ahead and do 249 plus 253 divided by 2. All right, and let's go ahead and plug that in. And what does that give me? 251, right? And one rule of thumb to remember, right, is once you find your Q1, for example, right, let's focus on Q3. So this is the last one we worked. This Q3 value must be between the, right, it has to be between these two values, right? If for some reason you got like 280 something, something's wrong, right? So you can always use that to check. And I would do the same thing here. And it's right, it's here, it's clear to see that the midpoint, right, between 234 and 236 is 245. So you always want to check, right, as you're going along. You always want to go ahead and check. And you can do the same thing with Q2, right? So what we're going to go ahead and find now, right, after you found Q1 and Q2 and Q3, is you want to find your IQR, right? This is going to be very important, right? Your IQR formula, right? And formulas like these, right? This isn't going to be on the exam, right? So again, right? Flashcards, right? Flashcards is what's really going to help us, right? The IQR, the interquartile range, is going to be Q3 minus Q1, right? Q3 minus Q1. And for those following the steps, we just found step 1. We're about to find step 2 right now, right? So my IQR for this problem is going to be 251 minus 235. Right, so my IQR is 16. Very nice. 16, right? Very, yes, 16. Awesome. Then step 3, right? Let's go ahead and label these. Step 1. First part was step 2. Step 3. Step 3 is going to get, you're going to multiply your IQR by 3 over 2, multiply it by 3 over 2, or in other words, you're going to multiply it by 1.5, right? So 16 times 1.5, right? And what does that give me? Let's go ahead and multiply that out. This here gave me 24. All right. That gives me here 24. Awesome. Now, what we're going to go ahead and do to find these bounds, right? We're gonna have, I'm gonna want to focus on my Q1. I'm gonna go ahead and focus on my Q2, and I'm gonna add this value, right? So in other words, to my Q1, right, my lower value. So visually speaking, right, I'm focusing on something like this. This is Q2. This is Q1. I'm gonna stretch Q1 backwards by this IQR times 1.5, and that's going to be my lower bound, right? Anything below that will be an outlier. And I'm going to do the same thing with Q3. I'm going to get Q3. I'm going to add it by the same 24, right? I'm going to create like this little fence, and everything above that value, right, in my data is going to be an outlier. So that's visually what we're about to do, right? So here, to find my lower value, right, to find my lower fence, right, this is going to be 235, which is Q1. In other words, if you want to find your lower value, let me go ahead and write down the formula for this, right? This is going to be Q1 minus IQR times 1.5. Right, that's pretty much that's pretty much the formula for it, right? Oh, I'm sorry, Q1, right? And to find your large fence, right? Your large value. This is going to be Q3 plus IQR times 1.5. All right. So let's go ahead and find that. Let's go ahead and find my lower value, which is Q1, which is 235, minus IQR times 1.5. That was 24. Right. So that means my lower value, right, it's going to be 35 minus 24. That's going to give me 211. Okay, I'm going to hold on to that right now, right? I'm going to hold on to that. So that's going to be my lower value. Let's find my large value. Should have just done that instead of LV, right? Because lower value and LV. So we'll say low val, right? Now for my large val, we said it's going to be Q3, right? Q3, which is 251 plus IQR times 1.5. We computed that. That was 24. So that means that my large val is 251 plus 24, 275, right? So now that you found these bounds, right, you're going to go ahead and look at your data, right? And you're going to see, right, and I'm referring to 220, 234, 236, all those values that you have here. Let's go ahead and shade them in, can't really shade them anymore. Let's go ahead and shade them in blue, right? All these are the ones I'm referring to. These right there, right? Something bright so we can know exactly which values we're talking about, right? And you're going to ask yourself, let's outliers, right? We're going to write here outliers, right? Your outliers. Let's see if we have any. I'm looking for anything below 211, right? I'm looking for anything lower than that left fence. No, I have nothing. 220 is my lowest. And again, here's the importance of writing everything in ascending order, right? Right, so none there. Now, do I have any, let's go to the right side, right? To the Q3 side. Do I have anything larger than 275? Aha, I do. It's 285. I'm sorry, 282. Right, so that means that my outlier for this, ooh, that's too dark. The outlier for this data set is 282. And we are done, right? This wraps up section 3.3. If you have any questions, please do not hesitate to send me an email. I have been responding to many of you, right? Many of you have also been setting up Zoom appointments. And like I said, this can be something you just need clarification. It can be 30 seconds, right? There has been a lot of 30-second appointments, and that's fine, right? I'd rather you have a 30-second appointment than, scratch your head on, why so-and-so was done in the book, and you have 3 hours that just went there, right? So by all means, just send me an email. If it's something pretty straightforward, I usually respond there. And if it's something too, like I said, too complicated, it can be something like 30 seconds, or what the other students have been doing is just setting up tutoring appointments, right? Which last about, about 15, 20 minutes. But it's also, let me also remind you all that there is tutoring, right? At Kingwood Library, right? At Kingwood Library, in person and by online, right? Appointment for both required, right? And setting it up is pretty straightforward. It's pretty easy. I've gone ahead and posted an announcement for that. You can go ahead and see more information regarding tutoring, free tutoring at Kingwood for statistics, right? At the tutoring module, right? Tutor and other resources module in the class page. Well, thank you all very much for your time. Enjoy the rest of your week, and be sure to complete these assignments by the due date. In the next video here would be section 3.4.